Hello, data rep number 6. This is the last day of data representations. Kind of. There's graphs and tables and everything, but this is the last day we focus just on the graphs and table stuff. We'll start reading more next time. So let's get into it. Last time I talked about a few questions from homework number 5. I'll go back and poke at those a little more. Data rep practice number 6. Well, you've seen this word already, but I'll continue to emphasize this word consistent, support, agree with. Those are all synonyms saying that the statement made matches up with the numbers that we gathered. We'll do a little word search for the word counterclockwise. We'll do more on direct and inverse relationships. That topic ain't going anywhere. You're going to need direct and inverse every time. So data representation homework number 6. Question number 5. A lot of people make up an answer on this one. Well, ACT is never going to ask you to make anything up. The second passage in your homework, there are 3 passages in the homework today, so a little more than usual, but not bad. I'm making these videos shorter, so it's okay. Match those goofy symbols. And the last passage has a question where you're combining information sources in a little different of a way. So let's get into it. Okay, looking at group work number 5, back on that sex-linked question on homework number 5, question number 5. Is this thing a sex-linked trait? So you gotta find kind of contradictions. Basically, it has something to do with mothers passing to sons. Is it always, did not always, did not always? Okay, so sex-linked is if mother always passes to the son. A mother with the trait always passes to the son. So you're going to look over here for mothers passing to sons, mothers with the trait passing to, so here's a mother with the trait has a son who does not have the trait. So it does not always, so you could cross out options. The always pass did not always pass, so it's a no because they did not always pass. And you had to look for a contradiction there. Mother always passing or not always passing to their sons. And this one was just goofy. Just a goofy one. You really got to look at the key on this one. I expect I gotta talk to you on this one. This one's really hard to, really difficult to do over the camera. So that one's a hard one. I encourage you to please talk to me about group work number 5, passage number 2. Getting on to practice number 6 for the day. So that's where we are. And I like this one. It's a fun little one talking about feeding some cockroaches. How do we catch the cockroaches? So you didn't have to know that, but we're gonna talk about it. So look at this. Oh my gosh! Beginning of the test. Those first few questions on ACT going to be easy peasy, hopefully. Let's jump right into it. According to figure 1, the mass of cheese remaining at 4 hours was closest to which of the following? Okie dokie. Mass of cheese remaining at 4 hours. So I got 4 hours. I got figure 1 right here. I got cheese as the white one. Mass of cheese remaining. I'm going to draw a little line over that looks to be something right around 185. So it's going to be answer option C for number 1. Drawing a line. You can do that one. Number 2. Suppose a company wanted to use food as bait in a trap. Okay, based on figure 1, which of the 4 foods should the company place in the trap to maximize the chance of capturing? The one that will maximize the chance of capturing, they ate the most, so will have the least remaining. How do we figure out what kind of, how do I figure out that you guys like the Flamin' Hot Cheetos so much out of the vending machine? They're never there. They're always gone. What had the least remaining? Looking over this graph, looks like the dashed one here has the least remaining. Looks to be peanuts that have the least remaining. So that's going to be answer option J there. You can do these. Number 3, consider the 4 foods in order, percent by mass of proteins, and I'm going to circle from lowest to highest. From food to food, as percent by mass proteins increased, what did the food remaining do? So as protein goes up, what did the amount remaining do? As protein went up, what does the amount remaining do? Well, how are we going to find out about protein? Okay, I see the word protein right here. Plus, okay, so cat food, cheese, ham, peanuts. As we went from cat food, cheese, ham, peanuts, what did the amount remaining at 28 do? Cat food to cheese, cheese to ham, ham to peanuts went down, down, down. So this decreased only. As protein went up, remaining went down. B, decreased only. Number 4, consider the statement. We got a statement here. Consider. The B Germanic ate the food between 0 and 4, between 4 and 16, between 16 and 24, and between 24 and 28. This statement is consistent with the data. That is, does it agree with the data? For how many of these foods? How many of these foods got eaten every time? That's what that question's asking. It's a really complicated way for which foods decreased every time. And you look over here and you say, okie dokie, the cat food went down a little bit every time. The cheese went down a little bit every time. The ham went down more considerably every time. Oh, baby, they love those peanuts. All right, so they all 4 went down every time. That word consistent is a word that we need to take a look out for. Does it agree? Does the statement agree with the data? Oh boy, number 5, we got a prediction. A student predicted that the B Germanica would eat less cat food than ham by the end of the study. Do the data in figure 1 support this prediction? Does it agree? So did we eat less cat food than ham? All right, so let's compare these. We started at 200, so that's how much cat food we ate, and that's how much ham we ate. If this was the starting amount, then that's how much cat food we ate. Not we, the cockroaches. And that's how much cheese we ate. So is it true that they ate less cat food than ham? Yes, they ate less cat food than they did ham. So I'm going to go over here and cross out the no's. And then I got to see what's the difference. Is it 55 greater or 95 greater? Excuse me, 55 greater or 95 greater? And I say, okay, well, between here and here, that's like 170 to 110. This gap right here looks like it's about 55. Answer option A. Last one. Now, based on table 1, when 200 milligrams of each of the 4 foods is placed in the box, water accounted for more than 100 milligrams. Well, hopefully you notice, well, let's look over at table 1. So I need to know something about water. I got water over here, and I got percents by mass. Okay, percents. Cool. So I noticed that what is 100 out of 200 as a percent? Hopefully you notice that's 50%. So we're looking for the things that are more than 50% water. That's what we're looking for. It doesn't say that, but that's what we're looking for. 100 out of 200, that's 50%. Which ones are more than 50% water? Cat food and ham. G. Cat food and ham only. Cool. We've done one. Cockroaches eat the peanuts. You want to catch your cockroaches, leave out some peanuts. Go ahead and pause it. I forgot to tell you to pause it last time. Pause it and give yourself a little 6-minute timer and try the next passage on your own, dealing with these RLC circuits. Do you know anything about RLC circuits? Probably not. I didn't learn about RLC circuits till calculus-based physics, freshman year of college. So I don't think you have, but you can answer questions because you can read graphs. Pause, give yourself a 6-minute timer, work the passage. Thanks for pausing. Let's go ahead and work through this guy. Again, you're probably not reading anything beforehand. Number 21, according to figure 2, the maximum positive value of Vs was approximately, okay, figure 2, right here. Vs is the dashed, maximum positive, okay, I assume I'm going over here to voltage. Looks to be right about 250. Quick one. Those first questions is like, hey, go find me a data point. Good job finding that data point. A period, ooh, gave me one of those italicized words. That tells me it's a definition. Is the time required for the wave to complete one full cycle. What does that mean? This much time. That's a period. That's what a period looks like. The wave goes up, the wave goes down, the wave comes back to the middle. Based on figure 3, the period for VL is what? Okay, well here's figure 3. VL is the broad dashes. Starts high at 0, goes low, and it comes back to the high at 20. So a period full 20 milliseconds. You had to know what a period was there. Period also can be peak to peak. A period can also be trough to trough. So the bottom to the bottom, the top to the top, or the middle on the way up to the next middle on the way up. So we can talk about periods like that. Trigonometry? Cool. Number 22, according to figures 2 and 3, which voltage varied the least? Varied, that means changed. Which one changed the least during the 20-second interval? Who had the narrowest band? Well, I got the V's. Big changes down here from positive 250 to negative 250. Who's got the smallest change here? The smallest variability looks to be for VL. Everything else has a larger variability. So the answer on that one's going to be CVL. Take a look. VC goes from up here to down here. VR goes from up here to down here. Which one has the narrowest kind of variability? Which one changes the least? That's going to be CVL. Cool. 3 to go. Then we'll set you off on your homework. Number 24 gives us another italicized word. This word polarity refers to whether a voltage is positive or negative. Based on figures 2 and 3, which two voltages were always opposite in polarity? That means when one is positive, the other is negative, or when one is negative, the other is positive. Who's always on the other side? No quick way to do this one, just by looking at all the pairs. Hopefully you notice that, okay, when the broad dashes are on top, the small dashes are negative. When the small dashes are on top, the broad dashes are negative. Positive, negative. Hopefully you see this alternating between the dashed lines being VL and VC. You would have had to go through those maybe pairwise to see if they're always on the other side. Number 25, 2 left to go. Based on figure 2, at which of the following times was the current in the circuit flowing counterclockwise? You should have looked at that word and said, huh? Time to word search for that word counterclockwise. You go through and you find it. Counterclockwise, negative current. And current is I. Okay, so when we got a negative current? 0, 5, 10, or 15. Here's my current. 0, it's 0. At 5, it's positive. At 10, it's 0. At 15, it's negative. What's it got to be? It's got to be 15. And then the last one. So you didn't know what counterclockwise, but you could look counterclockwise and negative. Last one, okay. Table below lists the electric charge in microcoulombs stored on the capacitor at 3 different times. Based on figures 2 and 3, from time 7 through time 13, did the charge on the capacitor more likely change in sync with I or VC? That word or that phrase, in sync, at the same time, in the same direction? Synchronized swimming. Are they in sync? Are they doing the same thing at the same time? So what do I see up here? Charge goes up, charge goes down. All right, so increased then decreased. You can cross out F and H right away because we know it needs to be increased then decreased. Did it do this better with I or VC? Well, let's go look at that. I at 7 is here, 10 is here, 13 is here. It looks like it's going down and down in both of those places. I at 7, 10, and 13, it's going down there. But VC, 7, 10, and 13, it certainly does go up there and down there. So that's why we're going to go with the answer option J. VC, over that time interval, both the charge and VC increased and then decreased. Hopefully you're giving yourself little pluses and minuses when we're seeing things go up and down in tables, and we need to be making some sort of account for those. So let's look at your homework real quick. A few passages I'd like to talk through. Group work number 6 here. Rolling over my cable. Mostly number 5. Mineral. Suppose that another mineral 3, has the chemical formula MnSiO3. Where would those intensities be? I would encourage you to look up MnSiO. You don't have to make anything up for that one. It gives you the information. I strongly encourage you to look at that. Middle one. You got a bunch of goofy symbols. Match the goofy symbols. You don't have to know what they mean, but you got to be able to find them. And then the last one, the question I'd like to make special mention of that you should probably be asking me over is 32. Based on table 1, the dielectric that fills the PPC in figure 1 is most likely which material? So I'm going to show you in figure 1. We've got this thing that goes from 2 to 10.4. And you've got to figure out the dielectric that could be responsible for that change from 2 to 10.4. You got 3 passages. This is your last data representation homework. Next time we'll start into research summaries. Later.